started. Roger.
Aurora 7, a capsule named by its pilot, astronaut Scott Carpenter, leaves Earth for the vastness of space. It's the second time the United States will send an American into orbit around the Earth. The first orbiting astronaut, John Glenn, launched a few months earlier and proved the United States could indeed successfully send a human being into space, navigate his ship in orbit,
Oh, that view is tremendous.
and come home to a predetermined spot on the planet. However, could NASA do it again? And if so, what difficulties might an astronaut face with a more rigorous experiment schedule on board? These and other questions await answers from Aurora 7. For months, the second Mercury capsule planned to take an astronaut into orbit had steadily been readied on Launchpad LC-14. Spacecraft number 18, fresh from McDonnell's assembly line in St. Louis, Missouri, has been placed above an Atlas D rocket and painstakingly readied for the next opportunity to leave Earth. The official mission objective is simple: corroborate man in orbit. The task, however, was anything but. It would be complex, sophisticated, and potentially dangerous. Project Mercury, named for the mythical speedy messenger of ancient Roman gods, was selected as the program name to take American astronauts likewise speeding into the heavens. The mission would be to study the physiological and psychological effects of space travel on the human body. In total, 20 Mercury vehicles were built and delivered to NASA at Cape Canaveral, Florida, between January 12, 1959 and May 16, 1963. Of the 20, 6 carry astronauts for a total 54 hours of flight time in space. A huge feat for a spacecraft the size of a Volkswagen Beetle. Starting in 1959, a total of 508 volunteer military service records are screened and whittled down to 110 active-duty military pilot candidates. From there, the number was finally reduced to 7. The Mercury 7, as they would be known. The word astronaut would still need to be invented.
Little bit of shaking.
The early morning launch of the Atlas D rocket was near perfect.
Pretty smooth.
However, trouble soon arrived as Aurora 7 slipped into orbit. As was experienced by John Glenn in the Friendship 7 capsule, the spacecraft's pitch horizon scanner, an important navigational device for properly aligning the spacecraft's orientation to the planet, had malfunctioned. Upon discovery of the malfunctioning scanner, steps are taken to manually correct the flight path. However, the adjustments only address a few of the problems that will plague the mission. During the first dark side pass, Carpenter maneuvers his craft to observe ground flare experiments in Australia. By too eagerly pulsing the maneuvering jets to rotate the capsule from side to side, the limited hydrogen peroxide fuel supply is depleted faster than ground controllers anticipate.
Fuel levels are lower than expected. I've remained in automatic. I can stop this excessive fuel consumption.
With the aggressive rotations comes an excessive heat buildup inside the capsule. Carpenter reports that sweat is interfering with his vision and making course adjustments much more difficult.
Last time around, someone told me it was 102. I don't feel, like I'm that hot. Cabin temperature is 101.
NASA flight doctors note a spike in Carpenter's body temperature.
We are reaching 102 right now. But as long as you feel okay right now. All right, I feel fine.
Which may explain the slowed speech pattern in various reports the astronaut had made to ground control. Engineers meet to plan an abort. However, a discussion with ground technicians and flight controllers resolved to continue the mission. Soon, planned observations of weightless liquid and orbital targeting balloons, photography of terrestrial features, and other meteorological phenomena are carried out. All the while, ground control stations around the globe maintain a watchful eye on the slowly depleting fuel supply. Unknown to Carpenter or anyone on the ground, another malfunction awaits. A timing mechanism for the retro rockets attached over the ablative heat shield and key to slowing the capsule for re-entry is not working properly. As the time for the rockets to fire automatically comes and goes, Carpenter must manually flip the trigger switch within a second. 2 seconds later, the light of the 3 rockets illuminate the night.
You have to use attitude bypass, man, and manual override. All right. 3, 2, 1, 0. Okay, fire 1, fire 2, and fire 3.
Although 3 seconds may not appear critical, when traveling over 17,500 miles an hour, or literally 5 miles per second, 3 seconds equates to 15 miles back on the ground. To survive his descent back into the thick atmosphere of Earth, Carpenter would need to gingerly coax what little fuel remained and make minor re-entry angle adjustments to control his falling capsule by manually steering the capsule and keeping the horizon in view through his one and only window. G-forces last longer than originally expected on the descent, but they are welcome as it means aerodynamic pressure is being exerted against the capsule and helping to keep an even trajectory on the way down. At 120,000 feet, Carpenter exhausts the very last of his fuel controlling the plummeting capsule. If he failed to do so, the capsule might have toppled completely 180 degrees and face topside down. Such an occurrence would point the drogue parachute in the wrong direction and snap the capsule back around so violently that the chute could be destroyed or severely injure Carpenter. Oscillations become worse, and the capsule begins to sway through a 270-degree arc, almost a full circle. Carpenter has no choice but to manually deploy the drogue chute early at 26,000 feet, 5,000 feet higher than anticipated, to stabilize the craft. He holds his breath as the 6-foot drogue comes out. In good shape, and the descent comes back into control. Soon, the altimeter shows 10,000 feet. Carpenter manually deploys the chute and slows the craft before splashdown. Back on the ground, Gus Grissom, the second American in space, and now capsule communicator, or Capcom, at Cape Canaveral Control Center, advises Carpenter he had indeed overshot his target area and that recovery teams were on their way. Approximately 45 minutes after his splashdown, 1,000 miles southeast of the Cape, planes from the USS Intrepid spot his location. 2 rescue swimmers soon leap from orbiting helicopters to ensure Carpenter is safe, and then proceed to secure a flotation collar to the bobbing capsule. A few hours later, the second American astronaut to orbit the Earth arrives aboard Intrepid, and then to Grand Turk Island for debriefing. Carpenter is later awarded the NASA Distinguished Service Medal by Administrator James Webb during a ceremony held at Cape Canaveral on May 27, 1962, on behalf of a grateful nation. His successful mission to carry out important tests and experiments will ultimately show the Mercury spacecraft system can be improved and become a stable and safe capsule for other manned orbital missions to follow. From Mercury to Gemini, from Apollo to the Space Shuttle,
the final liftoff of Discovery,
and eventually Orion. The contribution of Scott Carpenter and the thousands of men and women who helped get him to orbit and safely home started a legacy that continues to this day. a uniquely American legacy to learn and create a safe, durable, and reliable method for our astronauts to explore our world and those beyond the solar system. However, it is only a small part in the larger effort to pioneer the future in space exploration, to lead scientific discovery, and pursue aeronautic research here at home. Aurora 7, a critical step on the path to where we will walk tomorrow.